Okay, now we pick a point on the curve to be 1, 1. Okay, so again, I'm not going to pick one of these labeled points. That almost defeats the purpose. But let's just say that my favorite point on this graph, or the point that I deem most appropriate to whatever it is I'm trying to model, is here. So here would be x equals 1, and here would be y equals 1. Okay, because the instruction said pick a point and label it 1, 1. Okay, don't think I located that particularly well, but that's okay. Right, now we label the rest of the graph. Well, to label the graph, I'm going to cut 1 in half here, and I think right about here ought to be 0.5. And down here, okay, I'm going to come about halfway. Maybe that's right. That would be 0.5. Now I can cut that down more. If that's 0.5, then this is probably about 0.2 and 0.1 and 0.3 and 0.4, and then 0.6, 0.7, 0.8, 0.9, and I can do the same sort of thing down here. I'm thinking that 0.2 maybe ought to be about here. So 0.1, 0.3, 0.4, and then 0.7, 0.6, 0.7, 0.8, 0.9, 1. Okay, so now I've got a reasonable labeling of the graph. Let me make that 2 a little bit bigger, or a little bit clearer. Okay, so right there is a reasonable relabeling of the graph. Okay, now it was given that this graph that we just labeled is the graph of y equals x cubed. So if we wanted to estimate 0.5 cubed, we would come up here, we would come across here, and we would get something that looks like about 0.17. Now I happen to know that 0.5 cubed is 0.125, so 0.17 is a little bit high, but you understand what the graph would be telling us. Now the next instruction is we're going to do a different labeling of the graph, and we're going to use the point 210, the same point we used in a previous estimate. Okay, and let's see. I'm going to make that point about here. Okay, so I'm going to make this point 210, which means 2 is going to be here, and 10 is going to be over here. So that on the y-axis, that line kind of climbs a little bit as we move to the left. That's all right. We'll just kind of live with it. So 20 might be here, and 30 might be here, and 40 might be up here. Probably squeeze 50 in there, but we'll stop there. And if this is 2, then, well, halfway back to the origin, halfway between 0 and 2 would be 1. Don't know how well I did that. And then let's see if that's 1. That 1 is a little big. That's pretty good. Okay, maybe 3 is over here then. Okay, so now we have an alternate labeling, 1, 2, 3. Now, in case anybody's colorblind, I'll put circles around these numbers. And now our graph is of the form y equals ax cubed. That was given. And we're asked to find the value of a. Okay, now we're asked to determine the value of a, for which y equals ax cubed is the second graph, the graph where y equals 10 when x equals 2. So we're going to put 10 in here, we're going to put 2 in here, and we're going to solve that for a. And we get a equals 10 over 2 cubed, which is 10 over 8, or 5/4. So now our model for the orange labeling is y equals 5/4 x cubed. Now we're asked to do an estimate of y for x equals 1.7. Now here's 1, here's 2. So 1.5 is halfway between, right around here. So I'm saying x equals 0.7 is maybe about here. So let's just say that that's 0.7. Okay, just looking again at the distance between 1 and 2. This is not going to be a particularly accurate estimate, but let's just see what we've got. Okay, well, if this is 10, then this looks like it's maybe a little more than halfway. So we're going to estimate a value a little more than half of 10, which would be 0.6. So y equals 0.7 implies, x equals 0.7 implies y equals 0.6 with a big question mark. Okay, that should be x, and let me make that a little neater. Okay, and it's 1.7. I was looking at 7/10 of the way from here to here. Forgot that I had 1 there. So x is 1.7, and instead of 0.6, again, I was dividing this distance in 6/10 of the distance, but the distance is 10. Y is 6. Okay, so x equals 1.7. Our estimate is y equals 6. Now, we can check that against our function and see how well we did. Turns out I don't think we did all that well. Actually, maybe we didn't do that badly, because 1.7 squared is 2.89, a little short of 3. And if we triple that, triple 1.7, we get 5.1, so figure about 5. And 5/4 of 5 would be 6.25. So we do come out around 6, and that estimate of 3 here is a little high. So I think maybe we came out pretty well. Now I'm going to go ahead and crunch the numbers using a little bit of machinery. And let's see what we get. Well, plugging in 1.7, it turns out we are pretty close to 6, as I thought we would be. And that's actually better than expected, not based on my estimate of 1.7 cubed and everything, but based on the graph. There's some irregularities and anomalies on that graph, so we really wouldn't expect to be all that close to the 6. But in this case, we lucked out and did really well with it. Now we're also asked for the percent difference. Well, the difference is difference between estimate and calculated value is 0.14, and as a percent of the value, 0.14 over 6 is 0.023. Okay, and that is 2.3%. So our percent difference there was about 2.3%. Again, better than expected.